Hi everyone, my name is Carson Ritch. Today I'm presenting on the role of deep ocean currents in regulating Earth's climate. This topic is important because of deep ocean circulation is one of the most major systems that stabilize global temperatures, moves heat around the planet, and influence the weather patterns. Here's an overview of what I'll be discussing with you today. I'll start with the background information about the deep ocean currents are and how they work. Then I'll discuss the key issues, including how these currents disrupt heat and what factors disrupt them. Next, I'll share with you the research findings from leading scientific organizations and climate studies. After that, I'll discuss what findings mean for our future climate. And last, I'll wrap up with a conclusion and provided my reference. Deep ocean currents are part of the system called the thermoline circulation, which is driven by difference in water temperature and salination. Cold, salty water sinks to the bottom of the ocean near the poles and slowly travels around the globe before rising in warmer regions. This circulation acts like Earth's global conveyor belt, moving heat, nutrients, and carbon around the oceans because it operates at such a mass scale. It helps regulate global temperatures and keeps Earth climate stable. There are a few important areas that we need to focus on when studying deep ocean currents. First, these currents transport heat from the equator towards the poles, which influence the regional climates. Second, it disrupts the temperature or specifically from melting ice and weakens the circulation. Third, it changes the deep currents from the alter rainfall patterns, sea level rise, and extreme weather events. Research shows that deep ocean currents absorbs and store a huge amount of Earth heat. Without this heat storage, global temperatures could rise and much quicker. Studies also show that the deep current helps remove carbon monoxide from the atmosphere by transporting it into the deep ocean where it can remain for centuries. This process makes ocean circulation one of the Earth's most important natural climate buffers. Another major finding that climate change has already affected this circulation. Melting ice adds large amount of fresh water into the ocean, reducing and preventing cold water from sinking. Some of this climate models suggest that parts of the global conveyor belt, especially in the North Atlantic, could slow things down significantly. So, what does this mean? It means deep ocean currents are not just underwater movements, they are climate control systems. When these systems changes, everything that connects to it changes as well. A slowdown can make some regions warmer while the others, like northern Europe, becomes colder. It can also disrupt fisheries and marine food webs, even the economics and certain cultural regions. So another part, consider how long these changes last. Unlike atmospheric changes, ocean circulation shifts more slowly, but they also been been presented for centuries. This means that if deep currents weakens significantly, the effects could continue longer after carbon stabilize. Understanding this helps us better recognize why ocean research is more predicting long-term climate patterns. In conclusions, deep ocean currents are more of the Earth's most powerful climate regulators. They balance global temperatures, they store heat, carbon, and influence weather patterns. Current research shows that climate change is putting stress on this system. Disruptions could major global consequences. Recognizing the role of the deep ocean circulation helps us better understand climate change not just at the surface but throughout the Earth system. And here are my sources I use my presentations. When summarizing all I apply, I mentioned that my research comes from major scientific organizations such as NOAA, NASA, and Viewing Climate Studies, which strengthens the credibility of the information. Thank y'all.